This is a lovely question. Now, there are two important things you need to know. Point number one, f of x is continuous if the following conditions holds good. That is, limit x tending to from, because for this point is continuous at x is equal to 1, x is tending towards 1 from the left hand side, should be equal to limit x tending to 1 of f of x, which in turn should be equal to x tending to 1 from the right hand side. Now this is the condition for continuity. Now in short, f of x is continuous if the left hand limit equals the right hand limit. So I'm trying to tell you here is that limit x tending to 1 from the left hand side should be equal to limit x tending to 1 from the right hand side. If this holds good, then the function is continuous. Now condition number 2, f of x is differentiable if f dash of 1 with the negative sign being equal to f dash of 1 with the positive sign. So what am I trying to tell you here? I'm trying to tell you here is the function is differentiable only if its left hand derivative equals the right hand derivative. Now this might look little bit challenging, but let me show you how exactly whatever I just mentioned to you applies to this question. Now let me find out f dash of 1 minus. Now what is the meaning of this? This means x is going towards 1 from the left side. So we call it as x is approaching 1 from the left side. So how does it look? You have a 0 here, you have negative 1, you have positive 1. Now x is actually moving from this side. That means x is actually less than 1. Now go up over here. What is the value of the function when x is less than 1? F of x is equal to x. Now find out f dash of x. When you differentiate x, what do you get? You get 1. So therefore at x is equal to 1, f dash of 1 is going to be equal to 1, because of the fact that x is going towards 1 from the left side. So this is the part 1. First part you need to work. Now go over here for the second part. Part 2. What is this part? X is moving towards 1 from the right side. So obviously x is going to be greater than 1. So go up here. What is the functional value? The function takes x squared when x is greater than 1. It says greater than or equal to 1, so it also includes when x is taking the value 1 from the right side. So f of x is equal to x squared. Now find out what is f dash of x. That's going to be 2x. Now we are expected to find x is equal to 1. F dash of x when x is equal to 1. That's going to give me 2. Now for a function to be differentiable, f of x is differentiable if the left hand derivative is equal to the right hand derivative. Now check here. What is the left hand derivative? F dash of, this is actually x moving towards 1 from the left hand. So I can just place here negative. What is it equal to? 1. Now is this equal to f dash of 1 plus, that is when x is moving towards 1 from the right side? Are they equal? No. So this means f of x is not differentiable. Okay, this is one part of the story. If they ask you this question, you can very well answer this question in this fashion. Now, coming to the next part, this is called as continuity part. Okay, checking f of x is continuous. They might ask you also this. If f of x is continuous at x is equal to 1. So this is the property. I'm going to explain this property. Now this is 0, this is negative 1, and this is 1. Okay, now x is approaching 1 from the left side. This is x is approaching. That means obviously x is going to be less than 1. Now go back to the function. F of x is equal to x squared for x greater than 1, and f of x is equal to x for x less than 1. So in this case the function value takes x. So therefore find the limit of this function. Now what is this equal to? Limit x tending to 1, you can place the minus sign. F of x is equal to x. You apply the limits. Applying limits, what do you get? That means applying limits means substituting. In place of x I substitute 1. I get the value 1. Okay, fair enough. So I take it as 1. Equation 1. Now when x is greater than 1, that means x is moving towards 1 from the right side. So what is the functional value? Functional for all values of x greater than or equal to 1, f of x is equal to x squared. So f of x is equal to x squared. So therefore limit x tending to 1 from the positive side will give me, in place of f of x I need to substitute x squared. When you substitute x is equal to 1, what do you get? You get 1. So this is 2. Now from 1 and 2, what do you see? The left hand limit is equal to the right hand limit. So this means f of x is continuous. Now there is a very important question. Does continuity of a function imply f of x is differentiable? Very important. They will ask you. The answer is no. Continuity does not imply differentiability. Just because a function is continuous, you cannot say the function is differentiable also. So in this case f of x is continuous at x is equal to 1, but f of x is not differentiable at x is equal to 1. So that is the all important point you should know. Okay, we move on.